Hello, my dear students. Welcome you all for the Grade 9 Mathematics 19th Unit, the Pythagorean relation. So, my dear students, today we are going to learn what is this Pythagorean relationship and why should we learn this. At first, let's see why should we learn this. Pythagorean relation is a super important relationship in the universe. It is applying on thousands of job fields in all over the world. So, I guess now you may realize not only for your studies, in your future profession also, you will be required this knowledge. By studying this lesson, you will be able to develop the Pythagorean relation by means of a right angled triangle and also solve the problems related to the Pythagorean relation. Okay, now let's see what is this Pythagorean relation. Once upon a time, there was a Greek mathematician called Pythagoras. He had identified a special geometrical relationship between the length of sides of a right angled triangle. We call that relationship as Pythagorean relation or Pythagoras theorem. Let's learn this relation in this lesson. Before we learn the Pythagorean relation, let's identify what is a right angled triangle. We can categorize triangles into three types according to the magnitude of their interior angles. The first type is acute angled triangle. If the biggest angle in a triangle is an acute angle, we call it as an acute angled triangle. And the second type is right angled triangle. If the biggest angle in a triangle is a right angle, we call it as a right angled triangle. And the third type, obtuse angled triangle. If the biggest angle of a triangle is an obtuse angle, we call it as an obtuse angled triangle. Among these three types, right angled triangle is a special type. As I mentioned, if the biggest angle of a triangle is a right angle, we call it as a right angled triangle. Okay, now my dear students, let's focus on what are the special properties and characteristics available in a right angled triangle. Right. The side opposite to the right angle is called as a hypotenuse of a right angled triangle. And also the other two sides which contain the right angle is called the sides include the right angle. Remember this knowledge and we will use it again and again in this lesson. Now let's do an activity to practice that knowledge. There's a figure you have given with four triangles and you are asking to complete the table by using that information. Right, now let's see what you're asking. Okay, there are four triangles you are asking to find the hypotenuse and the sides include the right angle. At first, you have given the triangle AOB. Here you can see the triangle AOB, it is a right angle triangle since there is a right angle here. Okay, we know that the side opposite to right angle is hypotenuse. So AB is the hypotenuse of this triangle. And also angle include the right angle will be AO side and BO side. So the sides include the right angle is AO and BO. And next, the second triangle is COD. COD triangle is a right angle triangle, but you may see that you have not mentioned angle here. But you know that COD angle is vertically opposite for the AOB angle. So you know in your previous knowledge, vertically opposite angles are equal. So this is a right angle. Therefore, the side opposite to right angle is hypotenuse, then CD is the hypotenuse of this triangle. And same as before, the sides include the right angle will be CO and DO here. And the third one, EOF triangle. Now let's find EOF. Here is EOF triangle. Since it is not mentioned the right angle, we have to find is it a right angle triangle or not. According to your previous knowledge, you know that the adjacent angles on a straight line is 180. So you have mentioned one angle is 90 here, so the other also should be 90 to be 180. So this is a right angle. So same as before, the side opposite to the right angle is the hypotenuse. So EF is the hypotenuse here. And also the sides include the right angle will be EO and OF. And the fourth one, GOH triangle. Same as previous, since this is 90 degrees, this GOH angle also should be 90 degrees to be 180, since those are adjacent angles on a straight line. So here the side opposite to the right angle is GH, so it will be the hypotenuse of this right angle triangle. And also the angle, the sides include the right angle is GO and HO. Okay, now I think you can identify hypotenuse and the sides include the right angle. Okay, there's a small video clip here. You can see it. Carefully watch it and what's going on there. Right. Now let's see what is this special relationship presented by the Pythagoras regarding a right angle triangle. Just look at this small animated video clip clearly and be carefully, right? You can see there is a right angle triangle and also there are three squares have been drawn on the sides of that right angle triangle. And also you may see that the area of the square drawn on the hypotenuse has been separated into few parts, and those parts can totally cover the area of the other two squares drawn on the sides include the right angle. Okay, now let's see what is it. Actually, this is the exact relationship introduced by the Pythagoras. Now let's remember this with few sentences. The area of the square drawn on the hypotenuse of a right angle triangle is equal to the sum of the areas of the squares drawn on the remaining two sides. Okay, you can remember this theorem by reading it 2 times. Okay, now let's read it again. The area of the square drawn on the hypotenuse of a right angle triangle is equal to the sum of the areas of the squares drawn on the remaining two sides. Okay. Now, let's verify this Pythagorean relation on ourselves. Do you believe this relationship? Is it true? I guess no. Because we do not want to believe anything in mathematics without our self verification. Therefore, let's verify it ourselves. Draw a right angle with one arm is 3 centimeters and other arm is 4 centimeters. Then join two free ends by a line of those sides or those arms. Now you may receive a right angle triangle where the hypotenuse is 5 centimeters and the sides include the right angle are 4 centimeters and 3 centimeters. Okay, then just draw a square on side with 3 centimeters. Now just divide all the sides of that square into 1 centimeter parts as shown in the figure and have a grid like that. Now you may receive 9 small squares with 1 centimeter length and 1 centimeter breadth. And the area of that small square will be 1 square centimeters. Do the same on 4 centimeter side and have a grid, and you will receive a grid with 16 small square with 1 square centimeter area. Follow the same thing on the hypotenuse and have a grid with 25 squares with area 1 square centimeter. Okay. Now you may see that the area of the square drawn on 3 centimeters side is 9 square centimeters since there are 9 squares. And also the area of the square on 4 centimeter side will be 16 square centimeters since they have 61 square centimeters area. There are 16 squares with 1 centimeter square area with 1 square centimeter, right? Okay. The square drawn on the hypotenuse will be 25 square centimeters. Now just memorize the relationship presented by the Pythagoras. Pythagoras said that the area of the square drawn on the hypotenuse of a right angle triangle is equal to the sum of the areas of the square drawn on the remaining two sides. Now we can see here the area of the square drawn on hypotenuse is 25 square centimeters, and we can observe 25 by adding up 16 square centimeters and 9 square centimeters. So it is verified here Pythagorean relation is true. So let's say it again. The square drawn on the hypotenuse, it means 25 square centimeters, equal to the areas drawn on other two sides. Sum of the areas drawn on other two sides equal to the area of the square drawn on the hypotenuse. Okay, now let's build up this relationship another manner. If we draw a square on side AB, the area of the square drawn on AB will be AB into AB, it is AB squared. If we draw a square on BC side, the area of the square drawn on BC is BC into BC, it is BC squared. Okay. In same manner, if we draw a square on AC side, the area of the square drawn on AC will be AC into AC, it is AC squared. Therefore, the Pythagorean relation can be written as follows: AC squared equal AB squared plus BC squared. Okay, let's build up this relationship another way also. If the side lengths of a right angle triangle PQR are given by A, B and C as below, let's see how to build up the Pythagorean relationship. Now you may see that there's a right angle triangle with side lengths A, B and C. You know that according to the Pythagorean relation, the area of the square drawn on the hypotenuse should be equal to the areas of the squares drawn on other two sides. So we can write here the area of the square drawn on hypotenuse as A squared, and the areas of the squares drawn on other two sides as B squared and C squared. So we can write the Pythagorean relation as here: A squared equal B squared plus C squared. Okay, now let's solve few problems by using the Pythagorean relation. Example 1. Find the length of sides denoted by English letters on figures given below. There's a right angle triangle you have given with hypotenuse A and sides include the right angle 16 centimeters and 12 centimeters. Now you know that there's a right angle triangle. We can apply the Pythagorean relationship to this right angle triangle. So, as you know, you can write Pythagorean relation as A squared is equal to 12 squared plus 16 squared. By simplifying 12 squared and 16 squared, you may receive that 12 squared is 144 and 16 squared is 256. Therefore, we can write A squared equals 244 plus 256. By adding up 144 and 256, you will receive the 400. Then it is equal to the A squared. The problem is not all from here because you are asking A, the value of A, not A squared. So you won't remove this square. You know that to remove this square, you have to find the square root of both sides. So the square root of A squared is A and the square root of 400 is 20. Now you can write your answer as the length of the side. It is A equals 20 centimeters. Right. Okay. Now let's do another one. Here also you have given a figure with a right angle and the hypotenuse is 15 centimeters and the other two sides, one side is 9 centimeters and other one is x. You are asking to find the value of x. So what to do? Nothing more as previous. You know that if there's a right angle triangle, you can use the Pythagorean relation. So we can write the Pythagorean relation for this triangle as here. 15 square should be equal to 9 squared plus x squared. By finding the squares, you may receive 15 squares is 225 and 9 square is 81. So 225 equals 81 plus x squared. To find the value of x, you have to subject x in one side. So you have to remove 81 to the other side, as you learned in equation lesson and formula. So when 81 is going to moves to the other side, it will be minus 81. So you will receive x squared equal 225 minus 81. It means x squared equal 144. To find the value of x, as previous, you have to find the square root of both sides. So square root of x squared is x and square root of 144 is 12. Okay, now you can write your answer. X is equal to 12 centimeters. Wow, it is cool, isn't it? Okay, now let's practice it more and more with few examples. Here, example 3. Here also, you have given a statement. If the length of the side of the LMN right angle triangle are LM equals 6 centimeters, MN equal 8 centimeters, find the length of LN. Alright, you are asking to find the length of this side LN. So you have to do the same thing, because since it is a right angle triangle, you can write the Pythagorean relationship as here. Ln squared equal Lm squared plus Mn squared. Since Ln is equal 6 and Mn equals 8, you can write Ln squared equal 6 squared plus 8 squared. By finding the squares, you can write Ln square is equal 36 plus 64. So to find the value of Ln, you have to find the square root of both sides. Ln is equal to square root of 100. So you may receive the answer Ln is equal to 10. So now you can write your answer. The length of the side Ln is 10 centimeters. Okay, there's another example. You are given another right angle triangle with hypotenuse 13 centimeters and one side is 5 centimeters. You are asking to find the length of BC. Okay, same as previous. You can apply the Pythagorean relation for this right angle triangle. Square drawn on the hypotenuse, we can find the area of that as AC squared equal to AB squared plus BC squared. Since AC is 13 and AB is 5 centimeters, you can write 13 squared equal to 5 squared plus BC squared. By finding squares, you can write 169 equals 25 plus BC squared. To find the value of BC, you have to move 25 to the other side. So you can write here BC squared equal 169 minus 25. Here you will receive that BC squared equal 144. To find the value of BC, you have to find the square root of both sides. So you'll receive that the square root of BC squared is BC and square root of 144 is 12. So now you can write your answer. The length of BC is 12 centimeters. Right. Now again you are having a different kind of example. Here you are not given a figure, but you are given some information as a statement. Anyway, if you are given a problem or a question in your exam paper or any other way, just draw a figure yourself if they are not provided a figure. Okay, according to this one, I can see there's an angle called PQR. It is 90 and it is called that this is PQR triangle. Therefore, I can draw a right angle triangle here like this. And since the angle is on the vertex Q, since hat is there, I know that the 90 angle should be nearby Q. So the other 2 points should be P and R. Like that, I can draw this information in the figure. And also, since QR is 7 centimeters, I can mark it here, and since PR is 25, I can mark 25 here. Okay, now you have received a figure like that, and since it is a right angle triangle, you can apply the Pythagorean relationship for here. According to the Pythagorean relation, you can write PR squared equal QR squared plus PQ squared. Since the length of PR is 25 and QR is 7, you can write 25 squared equal 7 square plus PQ square. By finding the area squares of these two numbers, you can write 625 is equal to 49 plus PQ squared, since the square of 25 is 625 and square of 7 is equal to 49. By removing 49 to the other side, you can write PQ squared equal 625 minus 49. So, same as previous, you can simplify the numbers and you will receive that PQ squared equal 576. Then you can find the value of PQ by finding the square root of 576. So you will receive the value of 24 as the length of the side PQ. Now you can write your answer. The length of the side PQ is 24 centimeters. Now you may see that how much easy to use this Pythagorean relation and finding the answers for the questions related to the Pythagorean relation. Since it is curious, I'll give you another example. Okay, let's see. Wow, this is somewhat different kind of example. Here it says that a utility pole has placed vertically on a horizontal ground. One end of a ladder is placed 2 meters below the top of that pole, and the other end is placed 3 meters away from the bottom of the pole, as shown in the figure. If the ladder is 5 meters long, find the height of the utility pole. Okay. Here, you have given a figure, and if it is not given, you have to draw a figure according to this information. They have given that the ladder is placed 2 meters below the top, right? I have marked it here, and you are asking the height of this pole. To find that, I can't understand what should I do. Can I apply the Pythagorean relation here? But I can't see any right angle here, isn't it? No, you're wrong. There's a right angle. Where is that? We have not mentioned. It is a hidden information. In grade 6, you may learn these two words vertically and horizontally. There are two planes, vertical and horizontal. The horizontal, the vertical. You know that between two planes, one is horizontal, if other one is vertical, they are perpendicular to each other. Then it means there will be a right angle here. So now we can see this is a right angle triangle. So I can apply the Pythagorean relation for this. According to the Pythagorean relation, you can write the 5 squared is equal to 3 squared plus x squared. Then 25 is equal to 9 plus x squared. By simplifying this, by moving 9 to other side, you will receive that x squared equal 25 minus 9 and x squared is equal to 16. By finding the square root, of both sides, you will receive that x is equal to square root of 16. It means x is equal to 4. Now you can write your answer as here, x is equal 4 centimeters. But it is not the answer we have asked. We are asking find the height of the utility pole. So x is the value of here to here. Now you can see here utility pole will be this x plus this 2. So I can write it x plus 2. So since x is 4 centimeters, we can find the height of the utility pole as 6 centimeters. Therefore, the height of the utility pole is 6 centimeters. Okay, as a final example, there's another question. The city B is located 12 kilometers away to the east from A. The city C is located 16 kilometers away to the north from B. Find the shortest distance between the cities A and C. Okay, there's no available a figure here. So you have to draw a figure it yourself. Since it indicates some directions, mark north first and then draw it like this. Since the city B is located 12 kilometers away to the east from A, so here is A, B is located 12 kilometers away to the east from A. So I have marked it here. And again you are asking that the city C is located 16 kilometers away to the north from B, right? C is located 16 kilometers away to the north from B. Okay, now I have marked all of these information here. Okay, you're asking the shortest distance. It means the AC distance here. Since it is a right angle triangle, we can write the Pythagorean relation like that: AC squared equal AB squared plus BC squared. So then AC squared equal 12 squared plus 16 squared. So we can write AC squared equal, the 12 squared is 144 plus 16 squared is 256. By adding up those two numbers, you will receive that AC squared equal 400. To find the value of AC, you have to find the square root of both sides. So then you may receive that square root of AC square is AC, square root of 400 is 20. Now you can write the shortest distance between the cities A and C is 20 kilometers. Okay, now you can try the exercise 19.1 and exercise 19.2 and miscellaneous exercises on your grade 9 textbook. Practice exercises and verify your knowledge again and again. For your further knowledge, the great mathematician called Pythagoras was living on 540 to 500 BC in Greece. Just find out more information about him and expand your knowledge. So now, here is the end of the lesson, Pythagorean relation, in grade 9 mathematics book. Okay, finally, I'll add up my best wishes for your bright future. Have a nice day, dear student. Goodbye.